This is our first reinforcement sheet or practice worksheet for stoichiometry. I want to work out the even problems, so let's get right to it. Also, I posted the odd answers online, so again, use this to your advantage, not necessarily just copy the work down to say you got your homework done. Make sure that you're actually doing this and watching the video to help you understand what's going on. So let's take a look at number 2. Number 2 simply states or asks, given the following equation where you have 2 potassium chlorates yields 2 potassium chlorides and 3 oxygens, how many moles of oxygen can be produced by letting 12 moles of potassium chlorate react? So again, going through the 4 steps of stoichiometry, make sure you know these 4 steps, and you'll use these 4 steps for every single problem. First step is to write out a balanced equation. So the first thing that we must do is write out a balanced equation. Okay? So based on this problem here, we have 2 moles of potassium chlorate yields 2 moles of potassium chloride and 3 oxygen molecules, which is nice because it's already balanced for you. So I actually worked out the problem in balancing step 1 out for you. So step 1's done. Step 2, it wants you to take what's given, whatever the units are, and convert them into moles. And it could be in grams, it could be already in moles, it could be in molarity, which we'll talk about later on. I don't think I'm going to give you like atoms, but technically speaking, we could go there. You learn that in your mole topic. So convert what is given to moles. All right. And again, the reason why we have to change what's given in the moles is because if it's asking for how much oxygen and you're given an amount of potassium chlorate, those do not have the same molar masses. They don't weigh the same. So 1 mole potassium chlorate does not weigh the same as 1 mole of oxygen. However, if I have 1 mole of potassium chlorate and 1 mole of oxygen, I have the same number of particles. And when we look at a balanced equation, that's what we're really interested in. It's going to take 2 particles of potassium chlorate to form 3 molecules of oxygen. So that's the reason why we have to do this step. When we were doing the lecture and we were starting with a gram amount and then we were converting to moles and then going back to a gram amount, what a lot of the students were doing were they were thinking, well, we already have grams. Why do we need to change it to moles? Because it's not the same substance. So we have to change to the desired unit so that we can actually work with the moles to get rid of those alike terms or alike units. All right, step 3 is use the mole ratio. And again, the whole point of the mole ratio is so that we can get rid of the substance that we started with or that we know, like in this case we had 12 moles of potassium chlorate, and then convert it into moles of what we're looking for, moles of oxygen. So that mole ratio is used from the balanced equation, or actually we're going to use those values from the balanced equation to determine our mole ratio. And again, it's all based on how many atoms or molecules are actually changing from reactants to products. So make sure we use the mole ratio. And then step 4 is convert to whatever the desired units are. Okay. So the desired units in this case is asking for moles. Okay, so sometimes the steps are already completed for you. I may ask you for grams later on. I may ask you for kilograms. I may ask you for milliliters. Not today, but I could ask those very questions. All right, so make sure that you have these 4 steps memorized so that when you're working out a stoichiometry problem, every single time that you work out that stoichiometry problem, no matter how simple or how difficult, and I hate to say it, but number 2 is a very simple problem. I've given you the balanced equation. It wants your answer in moles. I gave you the answer or the starting amount in moles. So this is a simple problem, but later on, not today, but later on, you're going to have some more interesting problems. So let's actually work this problem out. Now, my recommendation, even though I've given you the balanced equation, I would personally still write it out. Just good habit, good practices. So we have 2 KCl O3s, and it forms 2 potassium chlorides and 3 oxygens. All right. Now again, my advice, and it's good advice, I would write down the information that I know about this problem. So like for example, it's asking how many moles of oxygen. So put question mark moles. Okay, it's asking for how many moles. Tell yourself it's looking for this. And then it also gave us 12 moles of KClO3. Okay, doesn't say anything about the potassium chloride. We don't care. All we do care about for the potassium chloride is to make sure that we have the right number of atoms, that it's involved in the balancing of the equation. And it's already balanced for you. So step 1, write a balanced equation. Done. Step 2, take what's given, 12 moles, and that's what's given. We don't know anything about the oxygen. That's what the question's asking. Take what's given and convert it into moles. Good news, it's already in moles. All right? So step 2 is also completed for you. And yeah, maybe on the test I might give a question like this. Step 3, we want to get rid of the moles of potassium chlorate. So I'm going to move it diagonally. I want to get rid of moles of potassium chlorate, and I'm looking for moles of oxygen. So I'm going to put my moles of oxygen on top. Now, the numbers that we put in front of these mole amounts won't be necessarily 1. Those values come from your balanced equation. So in this case, we're going to put a 3 in front of the oxygen because we have a coefficient of 3. We're going to put a 2 in front of the potassium chlorate because we have a coefficient of 2. The reason why we balance the equation is for step 3. And I guarantee you, every single question, you will have to write step 3 and determine it from step 1. So step 1 and step 3 are almost always a given that you have to do. Now, that was a gift there. All right, and then step 4, change into the desired units. Well, it wants it in moles. We have it in moles. So do your calculations. So 12 times 3 divided by 2. So let's go to the calculator. So 12 times 3 divided by 2. And it's 18. So 18 moles. And if you want to put oxygen, that's fine. But honestly, all I'm looking for is the number and the unit. Be sure that you are writing units within the problem. In other words, whenever you write moles of something, make sure you put what it is, moles of. Don't just get in the habit of writing 1 mole or 2 moles. Because if you didn't have that on there, that's going to look a little strange. I'm not going to know what that's 3 moles of and 2 moles of, and most likely you won't either. So be sure that you actually write those values on there. Okay, let's look at number 4. Number 4 says calculate the number of moles of methane, CH4, that will form if 24 grams of carbon react with hydrogen gas. So CH4 will form CH4, okay, if 24 grams of carbon react with hydrogen gas. So make sure you know what hydrogen gas is. If it ends in gen or INE, been saying it all year, then it's diatomic when it's all by itself. Now notice 2s don't carry. We don't carry. All right, so let's write down what we know. It wants to know the number of moles of methane. So question mark moles. If 24 grams of carbon. Okay. And that's all we know. All right, so step 1, write a balanced equation. Is that balanced? No. I have 1 carbon, 4 hydrogen, 2 hydrogen. So put a 2 there. Okay, doesn't really change anything, but sure makes it exciting. Step 2, start with what you know. In this case, we know we have 24 grams of carbon. Okay, so start with what you know and convert that into moles. We want to take that 24 grams of carbon, change it into moles of carbon. Oh, sorry. If it's not the unit looking for, move it diagonally. So carbon, and again, since we're doing a gram to mole conversion, that will be 1. It's not the mole ratio here. So 12.01 grams, get that from your periodic table. All of that is step 2. All right, so step 1, write a balanced equation. Step 2, change what was given into moles. And again, this is what we did last unit. Okay, and then we want to get rid of the unit moles of carbon. So we'll move that diagonally. And the question wants to know how many moles of methane. So we'll put moles of methane right there. Extend that just a little bit. All right, so now we have to ask ourselves, well, what values go there? Coefficient of 1, coefficient of 1. So we put 1s there. Sidebar. Since these are both the same value and they're both 1, is it necessary to even show that step? Absolutely. The reason is because if you look at it, this is moles of methane, this is moles of carbon. All right, we have to show this so that we can cancel out our moles of carbon. All right, so yes, it is very necessary to show that third step. All right, so be sure that you are doing that. Okay, so let me put that back in there. Okay, so now the question wants us to go to moles, so step 4, change to the desired unit. It's already in moles, so let's calculate. 24 divided by 12, it's almost funny to do it, divided by 12.01, okay. So it gives me 1.998, we're going to say that's 2. So 2 moles of methane. Pretty simple, okay. So again, step 1, write a balanced equation. Make sure you know who the reactants are, who the products are. Read the question, will form, react with. Okay, these are the things that you're going to have to key off of to be able to determine who are the reactants and who are the products. All right, let's look at number 6. Okay. Question number 6 says, calculate the number of grams of carbon dioxide that will be produced when 135 grams of butane react with oxygen gas. Also, water vapor is produced in the reaction. So calculate the number of grams of carbon dioxide that will be produced when 135 grams of butane, C4H10, react with oxygen. Also, water vapor is produced. Okay? So this problem, or this word problem, actually has things going all over the place. So make sure that you're asking yourself, who are the reactants? Who are the products? Make sure you know what you're starting with, what you're finishing with. Okay, so we have our generic equation. Let's write down what we know. So calculate the number of grams of carbon dioxide. So we're looking for the number of grams when 135 grams of butane. Okay, so 135 grams of butane. And now we're ready. So now we can start the question. And actually, let me scoot this so we get a little more room. And what's nice is, once you have that information written, you don't need to go back to the problem and look for information. That's what's nice. You know who the reactants are, you know who the products are, you know what you start with, you know what you're looking for. Okay. All right, so step 1, is this balanced? Well, we have 10 hydrogen here. If I put a 5 here, that's going to give me an odd number, so I'm going to double that. So now I have 20 hydrogen, so let's put a 2 there. Okay, so my hydrogens are balanced. My carbon, I have 8, so I'm going to put an 8 there. So my carbons and my hydrogens are balanced, so now let's do the oxygen. So 8 times 2 is 16, plus 10, which is 26. So 26 divided by 2, 13. Okay. So there is my balanced equation for butane. Start with what you know. So step 1's done. Step 2, change what's given into moles. So 135 grams of butane. And I need to change that into moles of butane. So 1 mole of C4H10. And again, that's, let's find the molar mass for that. So 4 times 12.01 1.01 plus 10 times 1.008. And let's get that real quick here. So 4 times 12.01 plus 10 times 1.008. So the molar mass for that is 58.12 grams. So let me write that. 58.12 grams. All right, and so now we have step 2. We have our mole amount, or we change what's given in the moles. So now I want to get rid of moles of butane. Okay, and I'm looking for moles of, I'm actually looking for carbon dioxide, so I'm going to put moles of carbon dioxide here. Let me extend that a little. Okay, so the value's there. Again, from the balanced equation, step 3. So I have an 8 for my carbon dioxide, and I have a 2 for my butane. Again, as I stated in the lecture, even though you have an 8 and a 2, and that can be reduced, leave it alone, all right? Because we've already reduced this down as much as we can here, so we don't want to try to get creative and put a 4 and a 1, and then later on when we're getting ready to study for a test or a quiz go, where'd 4 come from? Where'd 1 come from? There is no 4 or 1. Just leave it. You've already reduced it up here. All right, so we have our butane gone, so let's go ahead and find out how many grams of carbon dioxide. And so that's 12.01 plus 2 times 16, which I know is 44.01 if you use it enough. Okay, so now we are ready to calculate. Okay, so let's see here. Whoop, don't care about that. All right, so we've got 135 times 8 times 44. So let's see here. 135 times 8 times, what was it, 44? Yeah, 44.01. 44.01 divided by, and I'm going to open up my parentheses. And what do we got on the bottom? 58.12 times 2. Now what's nice is I don't need to retype since I already have it here, so I'm going to highlight U. And then I'm going to hit the enter button, it'll put it in there. Pretty cool. That's a nice thing about TI. And then times, and it goes a lot faster on your calculator, times 2. So times 2. So it's kind of like just hitting your answer button. It's kind of a neat feature. So we have everything in there. Let's close the parenthesis. And so 408.9, so we'll say that's 409. So 409 grams of butane. Okay, let's look at number 8, the last one. Calculate the number of grams of gold metal that will be produced when 20.3 milligrams of lithium metal react with gold 3 iodate. Oh, this is a good one. This is a great one to finish with. Also, lithium iodate is produced in the reaction. All right, so let's start with what we know. Calculate the number of grams of gold metal that will be produced. So we're looking for gold. Yay. So AU, when 20.3 milligrams of lithium metal react with, so lithium metal reacts with gold 3 iodate. Okay, so let's put that in there first. And then also lithium iodate is formed. Okay. All right, so we have some polyatomics in here, so let's balance some charges. Don't care about that because it's all by itself. What's the charge on gold? Has a Roman numeral 3, so that means it's a +3 charge. Iodate, actually let's make that an I. Iodate, one of your 10 polyatomics, has a -1 charge. So that means we need 3 of these. All right, we do not have 3 because of that. We have 3 when we put our parentheses and write a 3. Okay, so there's our gold iodate. Coming over here, our lithium iodate. Lithium is a +1 charge, iodate's a -1. That one's good to go. So, and that's what we wanted to do. We wanted to balance those out, make sure they were good. All right, so now let's write down what we know. So we are looking for the number of grams of gold. Looking for grams of gold. And we are given 20.3 milligrams, so mg, milligrams of the lithium metal. Okay, so that's everything. Let's balance this out. Obviously we're not balanced since we have 3 iodates here and 1 over there. So let's put a 3 there. So now I've got the same number of IO3s, 3 iodates. Now I need 3 lithium. Okay, and 1 gold, 1 gold. So step 1, balanced equation is balanced. Step 2, start with what you know. So we have 20.3 milligrams of lithium. Let's convert the milligrams to grams. Because we need to, because on the periodic table, everything's in grams. So when we look at grams and milligrams, you have to ask yourself, which is bigger, a gram or a milligram? 1 gram is bigger. And there are 1,000 milligrams in each gram. Okay? So we have our grams. Now we need to get it to moles. So we're going to go 1 mole of, what is it, lithium? Yeah, lithium. And the molar mass for that is 6.94 grams. Got that from the periodic table. Okay, so that's all step 2. All of this is step 2. We need to get rid of our moles of lithium. And we're looking for moles of gold. Okay. So let's find out what the values are. Again, we go to the balanced equation. So lithium is a 3. And gold is a 1. All right. And then the last thing that we need to do is convert the moles of gold into grams of gold. So we're going to put 1 mole of gold down here. And gold has a molar mass of 196.97. Okay, so 196.97. All this is. All right, so let's see, we had 20. Okay, so 20.3 times, 20.3 times 196, so 1 times 1 times 1 times 196.3. So 196.3 divided by, open your parentheses, 1,000. So we'll go 1, and there's an EE button there, 3. So there's 1,000 times the molar mass, 6.94. 6.94 times 3. Then close up the parentheses. Close it up. Enter. So 0.191, we'll say. Sounds about right. So let's see here. So 191, and that is grams of gold. All right, so hopefully this video has been helpful in helping you to set up the stoichiometry problem, go through the 4 steps for the stoichiometry problems, and you'll use those 4 steps every single time. Step 1, write a balanced equation. Step 2, change what's given in the moles. Step 3, use the mole ratio to get rid of what you started with to get what you're looking for. And step 4, change to the desired units.